The last colligative property that we're going to discuss is the osmotic pressure. And recall that osmosis is looking at solvent molecules passing through a membrane. So this can take place in both directions, but we're looking at the passage of a pure solvent going from the pure solvent side to the solution side. We're trying to reach some sort of equilibrium with concentration and pressure. So what happens is the liquid on the pure solvent side is going to decrease, the liquid on the solution side is going to increase, and that osmotic pressure is the pressure that's applied to keep the pure solvent from passing into the solution. So how much pressure is there? So what we're going to do is we're going to look at a more quantitative look at this so we can actually calculate the pressure value. So to represent the osmotic pressure, we use an uppercase pi. And the osmotic pressure is equal to molarity times some gas constant times the temperature. And just like with the other colligative properties, we may have to account for the Van Hoff factor if something dissociates. So big M is the molarity. So recall that molarity looks at moles of solute over liters of solution. R is the gas constant, and the gas constant that we will use is 0.0821 liter atmospheres per mole Kelvin. You could use another gas constant if you desire the pressure in another unit. But now the temperature, since we're using the gas constant, notice that the temperature is in Kelvin, so we have to convert our temperature into Kelvin as well. So here's a quick problem. Calculate the osmotic pressure for a 1 molar solution of glucose in water at 300 K. Okay, so here, glucose is a covalent molecule, so we know that the Van Hoff factor is 1. So we're going to use this equation. Sometimes people call it pi mart. Should be pi marty, but the osmotic pressure is equal to molarity times R times T times I. And here, this is our molarity. Our temperature is already given in Kelvin, so we can plug right in. We have 1 molar times our gas constant times our temperature. Then the Van Hoff factor is 1 in this case. So when we plug this in, the osmotic pressure is equal to 24.6 atmospheres. So you may be asked to find the osmotic pressure. You'd have to watch for temperature conversions, maybe actually calculating the molarity yourself, but the gas constant's always going to be a constant. And this concludes our discussion on colligative properties.